Hello everyone, welcome to ChemUp Academy, where chemistry is simplified and success is amplified. So this is to inform you all that we are launching a new batch for UPSC Geochemist. Also, those who want to prepare can enroll yourself. This batch is free for every student. And also one more thing, if you want to know complete details, there's a contact number that is provided to you in the description box. You may contact us, you may call us, or you can ask your queries. Coming on to our today's topic that we have, it is conductance. And this shall be your lecture number 4, and this is your PYQ session. Since yesterday we talked about the applications of Kholra's law, therefore application to पढ़ लिए. How are questions asked in your examination? We shall be talking about that. So that's why it is known. It is your PYQ session. So here, let's start with our questions. Okay, the first question that we have over here, I hope it is visible. Yeah. Okay. Near the value of concentration, this is your molar conductance of CH3COOH increases sharply on dilution. This is your first statement. You need to tell which statement is correct and which is not correct. So the question is, near lower value of concentration, molar concentration of acetic acid increases sharply on dilution. We all know that Kholra's law is basically used for weak electrolytes. And since it is used for weak electrolyte and this is a weak electrolyte, therefore this statement gets correct. Another thing it is saying that molar conductivity is observed by using Kholra's law of independent migration. Obviously, since we are discussing the questions related to that, therefore in an answer we can write that both the statements are correct. Coming on to our next question, this was just your tick mark questions, and this question came in your prelims year 2024. Coming on to the next question, we have, this is a sort of numerical. So it says that molar conductance of CaF2 at 18 degrees Celsius is given to you like this, and conductivity is given to you like this. You need to find the KST. In order to calculate the KST, we know the formulation which goes like KST into 1000 upon solubility gives your limiting molar conductivity. this was this is actually based on your fourth application that we did in yesterday's class. Alright, so in order to find that, we need to find the solubility because solubility is not known to us. In order to calculate the solubility, we have kappa. Kappa refers to your conductivity that is already provided to you in the question. Kappa into 1000 upon your solubility. This is how we calculate your molar conductivity. So what we can say is that, we can say that 1000 has to be maintained, molar conductivity at infinite dilution is given to you, and hence we can calculate the solubility. On placing the values in this equation, what can we solve? We can get for, this is your molar conductance like this, and here is your conductivity, that is kappa. These are the two values given. Now on placing the values, we can say that for molar conductivity we have 200 centimeter square mole inverse. Remember to write the units as well, upon 1000 into, it is saying the solubility we need to calculate. Okay. For solubility, let's take solubility over here. Solubility is equals to, placing kappa, the value of kappa is 4 10 to the power minus 5 into 1000, and upon, it is saying the molality at infinite, molar at infinite dilution, molar conductivity, that is 200. So on solving it, we can cancel it out like this. and like this it says 10 to the power minus 6 we are left with. Okay. Now another thing that they are saying is it is the solubility that we have got. Now placing this value of solubility in another equation, this value of solubility in this given equation, because what do we need to calculate? We need to calculate this particular factor. Now what we can do is okay, KSP has to be calculated. KSP is equals to upon 1000 into S. Here we have molar conductivity as 200 into S is your solubility, that is okay, here it is 2 10 to the power minus 6, and here we have upon 1000. So on solving it, you will get your answer from these questions only. Therefore, we have calculated our KSP. I hope this question is very clear to all of you. What happens is they have given us the molar conductance that is at infinite dilution. That means your this value is given and your conductivity value, that is kappa, is also given. From molar conductivity and kappa, we have calculated the solubility. After calculation of the solubility, we have come to the Holga's fourth principle or fourth application, which states that you can also calculate the solubility factor. So therefore, they were asking us to calculate the solubility factor. On placing the values, we can just solve it directly, and hence we can come to the solutions like this. Coming on to the next question. Okay, the next question says that it is quite simple. It says that kappa is given to you. That means the conductivity is given to you. Molar conductivity or molar conductance is also given to you. And for BaSO4 it is. So for BaSO4, it should be like this. Things should go like this. Therefore, how we can solve it? We can say that KSP you need to calculate. In order to calculate the KSP, again the same things are to be followed. Conductivity, molar conductance, like we have this, kappa upon the solubility into 1000. From here we shall be calculating first the solubility. After calculation of the solubility, let's calculate the solubility. Solubility goes like kappa 3 10 to the power minus 6 whole upon into 1000 whole upon 150. Okay, here we have got, on solving it we'll get 50 over here, and on solving it 1 times 20 times. So it shall be 2 into 10 to the power minus 5. This is your solubility. On calculating the solubility, now we shall calculate KSP. In order to calculate the KSP, we have the formula as is equals to whole upon we have S. Okay. It goes like KSP is given. Oh, sorry. KSP has to be calculated. KSP could be calculated like placing KSP value, molar conductivity 150 into solubility 2 10 to the power minus 5 and into becomes your KSP values. Like this, the similar question has been solved for you. Okay, since KSP is there, here we have S, here we have S. S is the amount that we are taking, and here we have S. Here also we were having S. So therefore, on solving it, we can solve such values and we can get the answer. Are they asking us to solve? Okay, KSP has already been asked. Coming on to the next question. Okay. Next question says that molar conductivity for Ba is given, for Cl is given. For BaCl2 you need to calculate. Remember the first law or the Kohlrausch law itself, which says that if at infinite dilution any electrolyte behaves as a sum of its molar conductivity of its ions. So just following that principle, we can solve this question. How? For BaCl2 we have Ba plus 2 plus 2Cl negative. Like this we can solve. Therefore, for BaCl2, M, BaCl2, we have what? At infinite dilution, we have M, Ba plus 2 plus 2 M, Cl negative. On placing the values, we will get BaCl2 as MBA is given 127 and here they have given 76 into 2 units we can write as S centimeter square mole inverse. On solving it, we can get our answer as 152 is equals to 972 S centimeter square mole inverse. This shall become our answer. Just applying the principle directly, that means at infinite dilution, weak electrolyte or the electrolyte behave as sum of its ion, molar conductivity of its ions. So, molar conductance at infinite dilution is sum of its molar conductivity of its ions. Just placing the values that have been given directly, and it is your PYQ for year 2023. Coming on to the next question. The next question says that for AgCl, remember we did it for KSP formula. While we were doing the KSP, we did this thing for KSP formula, which says that at infinite dilution, KSP into 1000 upon solubility factor was there. They have given everything, you just need to place the values like 50 over here. KSP has to be calculated. Oh no, the solubility has to be calculated. KSP for AgCl is given, that is 5 10 to the power minus 4 into 1000 upon S. From here 10 times, from here this 10 goes, and S becomes your 10 to the power minus 2. This is how you can calculate the solubility. Also, in order to know what are the units, we can place the units like S centimeter square mole inverse. For solubility over here, we have the units as S centimeter inverse. So mole per liter it need to come. So S goes with S, and here it is centimeter cube and mole. Therefore, mole per liter it will come. Centimeter cube it is now. So centimeter cube you can write as centimeter cube. Mole per liter, that refers to your solubility. This was a simple question and it is again your PYQ question. Coming on to the next question that we have, it says that molar conductivities at infinite dilution, for HNO3 they have provided to you, CH3COH, NaNO3 has been given. You need to calculate it for CH3COO, Na. So a simple question which says that how can I make CH3COO, Na from the solutions that have been provided to me? Like which are the solutions? HNO3 is there, acetic acid and NaNO3 are there. So how can we make it? We can add acetic acid with sodium nitrate and then we can subtract it from nitric acid. Like this we can do. And we can just place the values. On placing the values, what can we get? We can say that for CH3COOH, it shall be M for CH3COOH is given here. This is M for CH3COOH. That means 39.10. Then for NaNO3 we have 121.5, and for HNO3 we have is 421.2. On solving this particular thing, we can get our answer like 391 has to be added to this, so we can get it as 45 minus 421.2, and this goes like this. Like this, if you will solve, you can get the final answer. So this is how you can just solve questions related to Kohlrausch law and other principles of conductance as well. So this was all about today's class. All the PYQ questions have been solved. There are more to come, and keep watching, and thank you.
ChemUp Academy. Chemistry simplified. Success amplified.